Okay, this is 4.4a in college algebra, additional equations and inequalities. So what we're going to be doing is spending some time working with radicals and also radicals with rational powers. Okay, so anyway, we'll just start out with example 1. And again, like I've said numerous times, this is just review. If you've made it this far in your math career, you've done this stuff before. Nothing new, nothing really even more challenging. Pretty much what this book does is takes a lot of what you already know and just gives you story problems that are similar to ones you would encounter in real life. So, if you ever wanted to know when you'll ever use this stuff, well, this course is giving you a chance to see how that happens. All right, so as far as solving radical equations, there is a set of rules, 5 of them, on page 287. The 5th rule is the one most people do not do. All right, so we isolate the radical. That's the first thing we do. We square both sides, and we're going to do examples of this. If a radical remains, which will show that happens, repeat step 1 and 2, solve the resulting equation, and 5, all solutions must be checked in the original equation. Okay, so when you're doing radical equations, because the square root of 9 is actually positive 3 and negative 3, sometimes that really causes a struggle with radicals when you get two different answers, and then when you plug it into the original equation, one of them doesn't work. And that is called an extraneous, the book doesn't even use this word, I don't know, maybe it's not a word that's used anymore, extraneous root. And what that means is that one of the numbers doesn't work. So you have to, every time you do one of these, check and see if it works. All right, so in this particular one, example 1, one of the answers will not work. And so that gives you an idea of what's going on. So the first step is isolate the radical. So, okay, so it's isolated, because then we can square both sides and it gets rid of all of that junk, and we just have an x plus 5. Now over here is where it gets a little bit complicated, because we don't just get rid of stuff, we make it a little bit more complicated. So once we hit that, we again solve everything for 0. So we're going to move this stuff over here, giving me x squared minus 3x minus 4, and nothing is left over here, but let's put that over here just because I like it over there. No particular reason. All right, so we keep moving along here, and we solve for this. We try factoring it first, since that's usually the easiest way to do this, and in this particular one it works that way. So x equals 4, or x equals negative 1. So those are my answers, and normally you just leave it like that and life goes on. But because we started out with a radical way up here at the beginning, we have to plug this 4 in here and this negative 1 in here. So let's go ahead and plug that 4 in. Okay, whoops, sorry, that should be a 4, right? Okay, so we get 9, square root of 9 is 3, plus 1 equals 4. That's a true statement, so that works. Let's plug negative 1 in. Negative 1 plus 5 plus 1 equals negative 1. This gives me 4. And as you can see, that's not gonna, whoops, that's going to give me square root of 4 is 2 plus 1 is 3 equals negative 1. That does not work. So negative 1 does not work for this problem, only 4 does. So that's why you have to check it. All right, so let's go to example number 2, and we have a couple radicals in this one. Okay, So what we're going to do with this is we have the first step is to isolate the radical. Well, this radical is already isolated. So the next step is to square both sides. So we did that, and this changes to just 2x minus 5. This side over here gets to be a little messy. Okay, one of the things that makes it a little bit easier is that with this squared, if we're going to square this, we're just going to take this part under the radical, take it out of the radical. We're going to square that. And then what we're going to do is we are going to, because of this minus sign, we are going to put it there, a 2, and the 4x minus 8. Okay, so see what I did there? I just took the 4x minus 8, left it alone, put a 2 in front of it. Okay? That's all you need to worry about that. And this negative sign makes that negative. So that kind of makes it a little bit easier, is to be able to do this term, and this term. Okay, when you square it. Or you can do it the old-fashioned way. Whoops, sorry about that. That should be a square minus 1 times 4x minus 8 radical minus 1. Multiply those together using the FOIL method, and you will get the same answer that I did here. First one, second, middle term, last term. Okay, so anyway, let's pull as much of this stuff as we can over to the other side. So let's go ahead and isolate things. So we have 4x minus 7, gets rid of that, and that, minus 2 square root of 4x minus 8 equals 2x minus 5. All right, so we're trying to get this by itself. So let's get this and move it over here. So that gives me negative 2 square root of 4x minus 8 equals 2x minus 5 minus 4x plus 7. A lot of people get frustrated that I do this long, drawn-out process to do this, but I make fewer mistakes this way. Not that I don't make any mistakes, but it just seems like I make fewer. That would be x minus 1 there. Okay, once I'm at that point, I can square both sides. So it gives me 4x minus 8 equals x squared minus 2x plus 1. And again, I'm trying to get all my stuff on one side of the equal sign. So I'm going to move all of this, all this here over here. So I get x squared minus 2x plus 1 minus 4x plus 8, which gives me x squared minus 6x plus 9 equals 0. And as I look at this, I see that I'm doing it a lot different than the book is, but that's the nice thing about math, is a lot of times there are several ways to do this. And so my ending is x minus 3 and x minus 3. Again, my x equals 3, and it has a multiplicity of 2. We don't really care about the multiplicity here, but I know that my x is 3. So now I take this and go clear up into the original problem, put it in there, and find out that it works, so things are good to go. All right, which takes us to example number 3, equations with rational powers. And what we're talking about there are problems that look like this. And this is example 3. Okay, so what in the world do we do when we have an exponent that's a fraction, an exponent that's 2/3? Well, if you remember a while ago when we were showing this before, this tells you what the index is. So, radical. This 3 is the index, and this 2 is the exponent of that right there. Okay? And then that equals 4, because we're going to move that to the other side because we had to isolate the radical. Alright, so what in the world do we do with this? Well, since my index is a 3, we're going to cube both sides to get rid of the cubed root there. Okay, that stays x minus 3, the quantity squared, equals 4 times 4 is 16, times 4 is 64. Now, at this point, we're going to take the square root of both sides to get rid of this square right there. That should have been a plus or a minus square root of 64 there. When I take the square root of both sides, it's plus or minus. And the square root of 64 is plus or minus 8. So x equals 3 plus 8, or 3 minus 8. So that gives me 11, or negative 5. I try both of these, and what happens is I go clear back up to the very beginning of this problem, stick the 11 in, stick the negative 5 in. It works, and so therefore both answers are good for this particular problem. Okay, so before we go into equations in quadratic form, I'm going to start a new video. So that's it for video 4.4a.